We're going to do section 16.6 worksheet next, and this has two parts to it. The first part is asking us to look at reactions and classify them as being either oxidations or reductions, which is not something that we've really practiced yet. And the second part is asking us to predict the products of oxidation and reduction reactions. And since we just finished practicing that, this is what I'd actually like to start with. Then we'll go up and do the first part. So with all of these oxidation and reduction problems, I do encourage you to start by redrawing the original molecule. Doing this, it might seem kind of redundant, but it helps you get all of the carbon atoms in the right spot, get all of the existing oxygen atoms in the right spot, and make sure everything is in the right place. Once you get that molecule drawn, then you can change it based on what kind of reaction it's doing. So this reaction we can see is doing a reduction. There's hydrogen atoms that are being added. In that situation, we are going to remove carbon-oxygen double bond, turn it into a single bond, and we'll do that by adding a hydrogen atom to the carbon and the oxygen of the carbon-oxygen double bond. That's it. The next one that we see down here, we're going to redraw this molecule. This is an oxidation reaction. So in an oxidation reaction, there are two things that the molecule wants to do. The first thing that it wants to do, step one, it wants to convert its carbon-oxygen single bond to a carbon-oxygen double bond. So that's the first thing it tries. And for this particular molecule, we are starting with a carbon-oxygen double bond already. So in this case, it can't do this step one, or it doesn't need to do this step one because it's already done. So once that step one has been done, the second thing that it wants to do is squeeze in an oxygen. It wants to squeeze a little oxygen atom in, specifically to this type of carbon-hydrogen bond. So it wants to put it right there, which is going to give us this sort of a situation right here. Let me show you some things that it does not want to do, some squeezes that it does not want to make. So let's say that you have this. It does not want to squeeze into one of those bonds like that. Nope. It only wants to squeeze into a carbon-hydrogen bond specifically, not into any old bond. Oh, also, not just any old carbon-hydrogen bond. So let's say that we have, this right there. It doesn't want to squeeze into one of these guys right here. So not that either. It's not any old bond. It's not any old carbon-hydrogen bond. It's specifically this carbon-oxygen double bond with a hydrogen right on it. That's the only place that it wants to go. So don't try to stick it into any of these spots right here. Okay, so back to this molecule. Since we already have the carbon-oxygen double bond and we don't need to do that step, the next thing that it wants to do is find one of those special carbon-hydrogen bonds that it can squeeze an oxygen into. And this molecule happens to have one, so there we go. There's our product. Let's try the next reaction. So I'm redrawing the molecule without making any changes. I see that I'm doing reduction. I've got hydrogen that I'm adding, so that means that I'm going to take away one of the double bonds, and I'm going to add a hydrogen to the oxygen, and I'm going to add a hydrogen to the carbon, and that's it. That one is done. And now I have one more, and this is an oxidation reaction. So I'm going to start by redrawing my molecule. Remember, the first thing that it wants to do is convert a carbon-oxygen single bond to a double bond. So I'm going to turn that single bond into a double bond. When that happens, we are removing the hydrogen from the end of the oxygen. Let's see if we can stick a hydrogen up in there. See if we can fit it. I think we kind of fit it in there. There. Now don't forget, with the line structure, don't forget there's a hydrogen right here. Oxidation is not like a one and done thing. So once the first step happens in an oxidation, it's going to see if it can go ahead and do the second step as well. Do we have the right kind of hydrogen to be able to do the second step? Well, we do. We do have one of these special hydrogens. So that means that we are going to squeeze an oxygen into that particular bond.